Okay. Okay. So now you see there is we saw, of course, constructor, and then we saw the copy constructor, right? So in both cases there is a construction going on. Okay, so there is a new object being created somehow. Okay, and there is a initialization going on. Okay. um, so now, in case of copy constructor, we saw about two types of copy, like shallow copy and deep copy, and we saw that this idea of deep copy. I mean, you want to take control of the whole copy process using a copy constructor, because in many cases, depending on how your object is, so the compiler does not know. The compiler only knows the bitmap or the memory map of the object. Okay, but you want to take control of this whole copying process. So suppose, this deep copy is really a word, but you can have any level of depth. Okay, so depending on how your object is, so you want basically the control over the copy process. Okay, right? So now there is another situation where this copy process happens, which is in the assignment. Okay. So suppose let us take this particular example. Let's say let's say you have complex C1s and C2. Okay, these are being created. Okay, so the constructor is getting called. Okay, then this C3 is being created from C2. So here basically the copy constructor is getting called. Okay, but then you may do something like C2 is equal to C1. Okay, so there is no construction here. Okay, but there is a copy. Okay, so the object C1 is being copied to the object C2. Okay, so this is where your copy assignment operator comes in. Okay, so what is the copy assignment operator? Okay, so this is basically you can say the prototype of the copy assignment operator. Okay, so you see, it is, first of all, it is the assignment operator that you are overloading. Okay, so you have to use operator equal to. Okay, now the argument is going to be just like the copy constructor argument. Okay, so you basically pass a reference, constant reference to the to the thing that you are basically to the object that you are copying from. Okay, and of course it has to have a return value. Okay, so because the equal to operator has a return value, and then again the return value should be so here the thing to understand is that there is no creation process, right? So the current object is basically already there. So the object to which you are assigning, that object is already there. Okay, and that object's basically you are just changing. Yeah. So but this operator has to also return the reference to the current object. Okay, so basically here you can see that it is copying this c.re to re and then c.im to im. Okay, and then it is returning star of this. Okay, star of this by reference. Okay, so it is yeah, so basically yeah, so it is returning a reference to star of this. I mean, it could return like a value also. Okay, okay, so we'll come to this. Okay, but this is the copy assignment operator. So you see now in this, if you define the copy assignment operator like this, in this particular statement C2 is equal to C1, the copy assignment operator is called. Okay, and moreover, you can also do a chain of assignment. Okay, so here what is happening is first C3 is getting copied to C2 with the copy assignment operator. Okay, and then the result or the return value of this, which is C2 now, is getting copied to C1. Okay, so so this is how the assignment chaining works. Okay, so you can see that basically yeah, so one has to yeah, so CTAR, and then yeah, so you see here this copy is getting printed. Okay, so this is for copying of C1 to C2. Okay, so okay, and then twice the copy is getting printed, one for assignment of C3 to C2, the other for assignment of C2 to C1. Okay, and the other things are as usual. You can just check it. Okay. Okay, so this is the thing about copy assignment. Clear? Okay, so again here we are showing example. Okay, okay, so oh sorry. Okay, so so here in this particular example we are showing the same thing with the string function. Okay, so sorry, with the string class. Okay, so if you remember, we have the str and we have the len. Okay, this is the constructor. Okay, this is the copy constructor. Okay, and this is the copy assignment operator. Okay, now you see we are doing a deep copy here, so we want to copy this str also. Okay, so now there is this object s which you want to copy to the current object. Okay, okay, so if you do this copy, okay, okay, the current object, when it was created, it had this str, a string of its own. Okay, what will you do? You will actually take this s.str, which is the str of the incoming string. Okay, duplicate it, so allocate, make a copy of it. Okay, and then assign it to the current one. Okay, but if you do this without freeing the current str, then it will result in a memory leak because you are about to override this str. Okay, so hence you should first free this str and then do this, and then you return star this. Okay, so then if you do like you know, you have S1 football, S2 cricket. Okay, and then if you do S2 is equal to S1. Okay, and then if you print S2 again, you will see that it has now become football. Okay, so this is exactly how you know we expect it to behave. Okay, so okay, so important is here that while doing deep copy, you also have to take care to free the previous memory which was in deep copy. Okay, which was created during the construction or during a previous deep copy or something like this. Okay. Okay, now what happens if you do something like S1 is equal to S1? So this is allowed. Okay, so you know, in terms of variables and all, this is allowed. Okay, so variables of built-in data types, this is allowed. Okay, so in this case, what you do is that you actually free your input and the output is same. So you end up freeing the input thing itself. Okay, so for this reason, okay, you should actually check that the, you know, the thing that you are so that the input thing, you know, the input object is not the same object as currently. Okay, so then what do? You do the same operations. Was there a question?
Yes, sir.
Yes.
Sir, this garbage occurred because we are using the reference of the string S, or due to some other reason, sir.
Okay, so see, even if let's say it was not a reference, okay,
Yes,
even
sir.
if this was just a simple thing, okay, it would still, your str will still point to the same memory.
Yes, sir.
Okay, so still this problem will occur.
Yes, sir.
Okay.
Yes,
I
sir.
hope that answers the question. Okay. So, okay. So now you see, yeah. So how to, how to take care of this particular problem. Okay. So so the way to take care of this is that you basically check, whether the object, the current object is same as the input object. Okay. And how to check this? So this is the way to check that as we discussed, that the identity of an object is the best way to have this is that its address. Okay, so you just check this with the address of the input object. Okay, or the incoming object. Okay, and if this is the case, you don't need to do anything. You just need to return this. That's all. Okay, because it's copying onto itself, so no operation needs to be done. Otherwise, you need to do this operation. Okay. Um, okay. Okay. Yeah. So okay. So now yeah. So yeah. So basically, this is the typical. So this is the typical format of how you would define a copy assignment operator. Okay. You have this prototype, and then inside this if you basically put your copy logic. So however you want your deep copy to be. Okay. Um, Okay, so now you can also, yeah. So this is the common way. Okay, you can also pass a non-constant reference. Okay, like we discussed, in case of this, you can also pass the input object by value. Obviously, this is more wasteful. Okay. Yeah, because you don't want to copy the yeah. So whatever are the, you don't want to make a copy of the object that may take up time and memory. Okay. uh, then you can of course also return a constant reference. Okay. Okay, and you can also return by value. Okay, again that will both of these may have their own problems. Okay, so yeah, so the most common thing is this, that you return a reference and take a constant reference. um, any questions? So that kind of summarizes this whole module. Any questions? Okay. So now we go to we sort of revisit our access specifiers. Okay. So okay. So now okay. So okay. So now you see we have been seeing this whole constant business, in the context of some built-in data types. Okay. Now in case of objects or in case of classes, etc. Okay, there are three things we will look at. Okay, one is constant object. So an object of a particular class can be constant. Okay, constant member methods. Okay, and constant data members. Okay, and then we will look at something called mutable, which is a new keyword which has been introduced. Actually, yeah, not sure it is new, but anyway, so we will look at this keyword mutable, which basically which has a purpose in this context. Okay, so we'll come to it. Okay, so first is this constant objects. Okay, so what is a constant object? Basically, it is like that, your class is just a normal class. Okay, but now you define like, let's say, the name of the class is my class. So you define const my class A. Okay, so in that case, this object A is a constant object. Okay. Okay. Yeah. So now, if an object is constant, none of its data members can be changed. Okay. So this is number one. Okay. The type of this pointer of a constant object is const my class star const this. Okay. So if you remember, for a normal object, it is my class star const this. Okay, so the this pointer is constant, but it points to a object which is changeable or which is non-constant. Okay, okay. Now, this is the most key thing, that constant objects cannot invoke normal methods of the class. Okay. So this is a behavior. Okay, so this is something that the C++ compiler enforces. Okay, and the reason behind this is that these normal methods can be defined to change the object, right? So that is the basically the default behavior of a normal method. It is allowed to change the member variables. Okay, but now you see, because the object itself is constant, obviously its member variables have to be constant. Okay, but that cannot be ensured simply because the method will change the member variable. Okay, so that is why what the compiler does is it doesn't even let you execute the method. Okay, so this is the normal behavior. Okay, so here is an example. I think it is clear. So this is a my class. It has some public member, one private member, and then a get member, set member, etc. Okay, so if you define a non-constant object like this using my class, okay, you can do all this. You can say set member. You can say you can set the public member directly from outside. Okay, and you can of course say get member. Okay. Okay, now you see, when the same thing happens and you define a constant object of the same class. So the class is same, nothing has changed. Okay, the class definition is same. Okay, you are defining a constant object like this. Okay, then all of these will create error. Okay. So notice that this particular get member thing is not changing the class, not changing the object. Okay, but still you will get an error. Okay, even this print thing is, I think, not changing anything. Okay, so the print is also not changing anything, but still it will get an error. Of course, set member will get an error. Okay, and if you try to actually change the public member, that will also get an error. Okay. So the thing is, so this is the behavior. Now question is, how do you, but this should not be the case, right? So actually logically speaking, this get member and print should be allowed to execute because it is not changing things. Okay. So how do you do that? Okay. So the way to do that is, suppose at the time of defining the member function, what you can do is you can define the member function as a constant member function. Okay, so what does this mean? So first of all, the way to declare a constant member function or define a, okay, way to define a constant member function is like this, that you define the you basically put the function prototype, then you say constant, okay, and then you put the body of the function. Okay, so this constant keyword means that in this particular body you cannot change any member variable. Okay, so so basically at the time of compilation, if you do something something like my member is equal to I, then there will be a compilation error at this stage itself. Okay, so this set member will not compile. Okay, so so yeah, so this is the thing. Okay, now you see non-constant objects can invoke constant member functions. Okay, and of course the non-constant member functions, but constant objects can only invoke constant member functions. Clear? Okay. Yeah, so all member, so the takeaway is basically that all member functions that do not need to change the object should be declared as constant member functions. Okay, to in order to avoid this kind of problems. Okay. Okay, now, so this is the last example where you see this get member and print have now been declared as constant, and this will work. Okay, and of course, if you so you have this my constant object. Okay, so yeah, so the normal object my obj is the normal object, non-constant object. This can call all the functions. Okay, but my constant object can only call this get member and print function. It cannot do these two operations. Okay, so if you do these two operations, it will give an error. Okay, so this is about the constant member functions. Okay. Yeah, so there is one example here. Okay. Which again, I'm not, describing this example, but I would request that you read this example, okay, and just make sure, that you understand this example, okay. So this basically illustrates how you can, so you see, you can have like a class, okay, parts, parts of which are constant, parts of which are not constant, and so on and so forth, and they can have, other class objects and so on and so forth. Okay, so yeah, so this example basically explains that in a nice way. Okay, okay. Okay, so actually, let me stop here today. Any questions? So we will discuss the mutable thing in the next class, and we'll start from there. Any questions? Okay, then thank you very much, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.